Hi everyone, today you're going to watch your first debrief of an activity that you did in class. So what you need to take out is a different color pen and your worksheet. Hopefully you were able to print it. If you weren't, then you need to take out your notes from this worksheet. You should have been writing it down on paper so that you can make some notes in a different color pen on the paper that you were using. So we did this activity about what should be the school mascot, and we have, back in the day, they thought, should we be the Ballantine Bucks, the Knights, or the Prairie Dogs? So the first question you had was identify the individuals who and the variable what. So the individuals are who was being measured, and then the variable is what were we measuring about them. So who did we ask? Students. What did we ask them? What's our mascot? And so that's going to be a really important distinction between those words. We're going to use those words a lot as we move forward in statistics. Now the variable, remember mascot, is it categorical or quantitative? And so you just had to think about that using the words themselves. Categorical. Categorical means categories. Just going to put a little line. Oops, I don't like that. Just going to put a little line over here. Placed into categories, which seems like we're using a word to define itself. So I'm going to write groups. And these are the individuals that got placed there. And then quantitative would be numerical. But the most important thing about that is there's some numerical things that are actually categorical, like zip code or area code. So I like to put a little note there that says can take a meaningful average. So I wouldn't calculate the average zip code, for example. Now look at these. This is called a table, a frequency table. These are counts. So I'm going to label those as counts. Those are numbers, but they're being used to place the individuals in the categories. These counts are represented by individuals. So we could have used tally marks, honestly, instead, but I don't want to tally 300 people that picked Knights. So those are counts, and that's for categorical data. All right, moving along to number 3. You guys were asked to enter the class data in the Statplet applet, and so we have a bar graph and a pie chart. This should be obvious, but we're going to label bar graph on top of the one that has bars and pie chart on the one that looks like pieces of pie. There's one important thing about a bar graph. Your y-axis must start at 0. This is one of those things that news sources can manipulate to make the differences between the groups look more drastic. So if they don't start at 0, then and you start too high, it could make the difference between the groups look really crazy. And they're like, oh, wow, this group has way more than that group. But if you start it back at 0, it's not as big of a deal. So that's one thing that you want to look for when you're looking at graphs in the news. And then a pie chart, it must be part of a whole. So it makes a whole pie. It's got to add up to 100% for that to work. You can't choose more than one mascot and be represented by pieces of the pie that way. Okay, so here we have more than one variable. We have teachers versus students is one variable, type of person, and then mascot is still our other variable. And so this is called a two-way table. And we can label this other one as a one-way table. One variable. Here we have two variables. And so you see them cross. These are still counts. Each of these still represent a person that is a student and likes prairie dogs. For example, 50 people were students that liked prairie dogs. So then we have these percentages that should have been pretty easy to calculate, but they do have special names that we will refer to moving forward. So percent of all people who chose prairie dogs. Okay, well, let's see. Prairie dogs, all of them. That was 60. We totaled that, and I'm going to use a new color here to 60. And so that number was not part of the original table. It's in the margins. And so all of these numbers here are, even this one, margins. So any values that are calculated from the margins like this with the number 60 in the numerator is called part of a marginal distribution. And we'll talk more about that in the important ideas. But those I can finish tallying these. We have 310, we have 230. That totals to the whole group of 600. I always like to make sure I did my math right there. And then we have 100 and 500, which should also total to 600. All right, moving right along. The margins are not part of the table, so that's why we call it marginal. It's on the outside. Part B, percent of people who is a student and chose nights. So student and nights is a number from inside the table, and it's like a cross between one variable and the other. And so we call that a joint relative frequency. Joint because it crosses over, relative frequency because that means percent, which we'll include in our important ideas. And then the last one, percent of teachers that chose Buccaneers. So in this case, it was out of all the teachers, which is a new denominator, 100. And then of those, 80 chose Buccaneers. And so this was based on the condition that someone is a teacher first. And so this is called part of a conditional distribution. Because it was based on the condition that someone was a teacher. And we can use, I say part of for A and C because we can calculate all the values that are part of that. Every person that was a teacher that chose each type, we can calculate their percentages. So number 5, how many variables does the table have? Are the variables categorical or quantitative? And so here we talked about 2. We have type of person. I'm just going to label it here. Teacher or student, and then we also have mascot. People fit into categories, so that's why it's so categorical. All right, moving on to number 6. The table above displays results in a different way. So all these are our percentages and what's going on in this table. And so it displays the percent of people in the individual category who chose each mascot. So it tells us, we already saw this 80% here. It was 80 over 100, and then also they did 10 over 100, 10 over 100. So I'm going to label those in here. Oops, then it's not 8 anymore. So that makes this bottom one, 30, 60, and 10. I'll go back to this picture again. 150 over 500. These were the students. Oops. And then the 60% would have been the 300 over 500. And that 10% would have been the last group, which would be 50 over 500. And so this is called a conditional distribution, the whole thing. You can make a brand new table out of it, and it's got the row totals as the denominators, and I'm going to say conditional distribution for type of person. And so that is what that is. Number 7, you should have been able to create these 2 bar graphs, pretty simple. And then on the number 8, it said to stack them, taking each bar and stacking them. We call that, I'm going to draw a little arrow over here, a segmented bar graph. And you might have already adjusted your number 8 graph for the last question on here, but this is just going to stick with what the answer was when you originally did it. Another word for that is, we also can call it a stacked bar graph. And notice that it totals to 100% because we took these bars and stacked them on top of each other, which represented all the teachers, 100% of the teachers and 100% of the students. And so that's what we see here. And then you can see the percentages, how they correspond in the table. All right. But remember, if you think about it, well, now they say, let's look at these displays. It looks like the Bucks, which is in the blue, has the most support. If you put those two together, teachers and students, that's way more than the orange or the light blue. And so that's the biggest, and that's why we want to pick it. But a lot of people might argue that we had 5 times as many students as teachers. And so we asked, how can you adjust your graph in number 1, your third graph to take, not number 1, I'm sorry, but number 8. Just your third graph in number 8 to take into account the sample size. And so this is one you could have really done a bunch of different things. But what we were thinking is if I have 5 times the size, I should make the students 5 times as wide. And a graph that takes into account sample sizes like this is called a mosaic plot. We're not going to worry too much about it. You don't ever have to draw one of these on your own again, but you will need to be able to read one. And so here we can see that the student group is much larger than the teacher group. And this graph shows us that. If you look back at the segmented bar graph, you can't tell a difference in sample sizes. And so it's hard to tell which one had more weight overall, but the mosaic plot will tell us the differences in the sample sizes. And the area of the boxes tells us what we want to know about both sample size and relationship to the other variable. Okay, what should they make the mascot now? Look at that box. Look at this Knights box. It's huge. So we're going to say go Knights. Clearly has the most support. And it won. This is a true story. They used a mosaic plot to determine it back in 2007. Okay, important ideas. Keep your red pen out. We're going to finish that. And then I'll have you pause and do the check your understanding. But let's do the important ideas first. Okay, so I'm just going to show you this for a second. You can pause to get it all written down. What I have is an example of a two-way table and then some vocabulary that we're going to fill in. And so I just want you guys to pause, copy this down in your box or on your notes, on your notebook paper, and then we'll fill in some information about it. Okay, first piece of information is that a relative frequency is just a percent or proportion. Remember, the word relative means like when you're comparing, how did you do relative to your class? Well, relative to my class, then you want to look at, oh, I did better than 80% of my class. And so that is what we would turn into a proportion, relative. Frequency means percent or proportion. This two-way table is always got 2 variables like we saw, and then each variable will have its own set of categories. Like we had type of person had 2 categories, teacher and student, and then the other category, sets of categories were mascot. Mascot had 3 categories, and that was Buccaneers, Knights, and Prairie Dogs. And so you can put the table in any order that you want. This one is different than the other. It doesn't matter. They're all the same. So what I'm going to do is I'm going to label each of this. I'm going to put a little A here. We're going to label all of the insides as A because they all have the same kind of properties. Then we have B on the outside. And then we're going to make the table total C. So don't forget that the totals are, I'm going to just use a different color. The totals are not part of the original table. That's why they're dotted lines. They're the margins of the table. So a joint relative frequency would be like A over C. Any value from the inside over the total. The marginal distribution would be like any value from the outside of the table over the total, and then a conditional would be any inside value over a margin value. And so that's like A over B. The marginal is going to be row or column total over table total. And you can do one for each variable, one distribution for each variable. And then conditional distribution is going to be joint over row or column, depending on the question. So we're going to keep looking at this. I had to erase or cover it up. So let's start with segmented bar graph. I'm going to uncover this for you guys to write down. A segmented bar graph is a graph that shows the conditional distribution of one categorical variable. So what it looks like is if we draw a little graph here, and then we have two 100% tall bars, and then there's a couple of different variables represented in it. So that's segmented to 100% tall bars. I'm going to put 100% right there. And then we have two variables here. All right, next we have a side-by-side bar graph. So that would be if I just took that stacked bar graph I just made and then made it side by side instead. Use that purple again. So I still have my two variables, but this time I'm going to have the dots followed by the white, followed by the shaded in, and then I'll have my dots followed by the white, followed by the shaded in. So you just take the bars and unstack them, basically. Both are fine. We're not picky about which one you draw yourself, but we just need to be able to read both. The mosaic plot is one that shows you the sample sizes. So make sure you write that definition down. A segmented bar graph where the amount of individuals in each category adds width to the bars. So we would look at that up there. And in this case, I would have, maybe I have the first group is smaller and the second group is bigger. Then we have this little guy and this little guy, and then we have these. So I add width, and I still have my two variables. Not variable one, variable two. It should be category one, category two. Sorry about that. Okay, then the last thing I have on here, which is really important for FRQs, is that you're going to be asked to describe an association. And so we want you to compare across groups with specific percentages. There's going to be an example in the Check Your Understanding about that. And so I want you to give it a try. You have to use percentages, and you have to be specific about it when you compare the different groups. But just give it a try, and then you can check your answers with mine and see how you do. And make sure you just go ahead and pause this video, complete the Check Your Understanding, and then you can come back to this video when you're finished to look at the answer. All right, so here's the answer key to the Check Your Understanding. Here they say, explain how the sizes of the boxes relate to the numbers in the two-way table. This is a mosaic plot. I can tell because of the format. It's got it looks like a segmented bar graph, but the bars are different widths. So that's how you know it's a mosaic plot, besides the fact that they told us. So the areas of the boxes correspond to the percent of the total group for each cell in the table. And so you can see how they work. You don't have to ever find the percentages yourself from the mosaic plot or create a mosaic plot yourself from a table. all you need to be able to do is read one. So next, B and C, this makes up a conditional distribution, the whole thing, for juniors and seniors for the variable. So we have juniors as the denominator in letter B and seniors as the denominator in letter C. We could have made a whole new table if we wanted to. But this just asked us specifically for the separate values. And so then I was able to use that in D the way I used, see how I used specific percents every time. And I compared proportions, not amounts. You can never, I'm going to write this in red, never compare counts. Always percents. And we can talk about how the news does that incorrectly sometimes. People try to compare numbers and they say, oh, more people of this creed fit this category than that. And so if they're comparing actual numbers, it's not appropriate. They should be comparing percents, and makes it more statistically accurate and meaningful. That's it for today. Next thing you should do is your your Unit 1 Day 1 assignment in Zeppelin. Let Mr. Crouch and I know if you have any questions. Have a great day.